Hello Longhorns, we are getting ready to do our PreCal fourth 6 weeks test. So this is the test review for test 4.3, and you'll notice at the top here we have these 4 formulas which you should be able to recognize by now, and also you will have the formula chart that we'll be giving you during the test. So let's get started with the review. All right, in this question we need to find each angle measurement in radians. So the first thing you need to do is identify your sides of your triangle and your angle. So right here we have the angle that we're identifying. We're looking at this angle. And this side in relation to that angle is the side opposite. And the other side that's numbered is the hypotenuse. So we know it's the hypotenuse because it is directly across from the 90-degree angle. So we know that that value of 24 is our hypotenuse. Okay, so the way we find the angle measurement is we're going to use the inverse trig function. So the trig function I need, since I have an opposite and I have a hypotenuse, I'm going to use the sine inverse function. And then I'm going to write down my ratio, which is 12 over 24. And I put that in my calculator, and I get this decimal 0.5236, which is the angle measurement in radians. So this question is telling me, or asking me to give the answer in radians. So if your calculator gives you a decimal like this, that's radians. Now, if your calculator is in degree mode, you're not going to get the radians. So you might want to change the mode of your calculator to to radians, so that you can get the correct radian measure. Okay, the next one here is our angle, and this is the side adjacent, and this is the hypotenuse. So this time we're going to use cosine inverse. So cosine inverse, and then our ratio is 13 over 20. And in radians we get 0.8632. Okay, let's move on to number 2. Okay, for this question I'm going to give you a quick review on what a reference angle is. If I take any angle on my circle, and if it's not in quadrant 1, say it's in quadrant 2, quadrant 3, or quadrant 4, the reference angle that I can use in order to solve problems is going to be the angle that will get me back to 180 degrees. So in this case, this example that I've shown you right here, it's probably somewhere around 330 degrees. Its reference angle would be this angle right here, would be this 30-degree angle that would get us back to the horizontal. So when we're looking for a reference angle, we want the measurement of the angle that's going to get us back to the horizontal position. So let's take the number that we've got here. We have a negative 520 degrees, and we need to find the reference angle. Well, the first thing I'm going to do is find a coterminal angle that's going to be in between my 0 and 360 degrees. So let's do that first. Okay, so I've added 360 degrees, and the first time I added 360 degrees, I got negative 160. Well, that's still a negative angle, so I needed to add 360 degrees one more time, and that got me to 200 degrees. Now that 200 degrees is located in quadrant 3. So let's take a look at what we're going to need for a reference angle to get back to the horizontal position. Okay, so I know that my 200 degrees is approximately right here, and it's in the quadrant 3. So the reference angle I'm going to use is whatever this amount is to get back to the horizontal position. So if I take the 220 degrees and I subtract 180, that will get me back to this horizontal position. So I'm going to subtract 180, and when I do that, I get 20 degrees. And that is my reference angle. So this angle right here would be 20 degrees. All right, in the next question, we're converting a degree into degrees, minutes, and seconds. So we're going to keep the 88, and then we're going to take the 0.215, and we're going to multiply that times 60. And when I multiply that times 60, I get 12.9. Well, I'm going to keep the 12. That's going to be my minutes. So now I have 88 degrees and 12 minutes. Well, now I need to take this 0.9 that's left over, and I need to multiply times 60 again. And when I do, I get 54. And that's going to be my seconds. So my final answer is 88 degrees, 12 minutes, and 54 seconds. All right, question 4. Now we're going to convert from degrees, minutes, and seconds back into decimal. Now when we're doing this one, we have to divide instead of multiply. So it's a little bit different. So let me move this up. And we're going to take our 15 degrees, and this time we're going to put a plus sign because we're going to add these other parts. We're going to take the minutes and we're going to divide by 60 because there's 60 minutes in a degree. And then we're going to take the 30 seconds and divide by 3,600 because there's 3,600 seconds in a degree. Then we just put that in the calculator, and we get 15.2583 degrees. And that's it. Okay, question 5 is a question about linear velocity. So we're going to grab our linear velocity formula from our formulas at the top of our test. And this one is going to be V equals R theta divided by time, where R is the radius, theta is our angle, and T is time. So it says calculate the linear velocity of a reflector located 9 inches from the center of a bicycle wheel, rotating 5 pi radians per second. So we want to express our answer in terms of pi. That means when I do my calculations, I'm not going to multiply anything times pi. I'm going to leave pi alone. Pi is going to be part of my answer. So my radius is 9. My angle measurement is 5 pi. So 9 times 5 pi. And the time is 1 second. So it's per second. So since I am not going to multiply times pi, all I'm going to multiply is the 9 times the 5. And 9 times 5 is 45. We're going to leave the pi in there as part of our answer. And this is feet because we are, oh, I'm sorry, inches. It's not feet, it's inches. So this answer is in inches. So it's 45 pi inches per second. And that's all you have to do. Do not multiply your answer or multiply your problem by pi. We want to keep our answer in terms of pi. Okay, so here's another word problem where we have to use one of our formulas. Number 6 says a lawn sprinkler located at the corner of the yard is set to rotate through pi over 8 and project water out 16 feet. So what area of the lawn is watered by the sprinkler? Express your answer in terms of pi. Again, we're not going to multiply through with pi. You're going to leave pi alone. But we're going to go ahead and pull the area formula from the top of our test and write it down so that we have it handy so that we can put all of our values into the formula. Okay, so the area formula is 1/2 r squared theta. So we're going to go ahead and leave our 1/2 just like it is. The radius in this case was 16. So we're going to use 16 squared. And then our theta is pi over 8. Pi over 8. Now remember, when you are putting this in your calculator, you are not going to multiply anything by pi. So when you put it in the calculator, you're putting in the 1/2 times 16 squared times 1/8. And when you do that, you get 16. And then we have our pi. So it's 16 pi feet squared. And that's it. All right, the next problem is if the terminal side of an angle theta goes through the point -12, -5, find the sine, cosine, and tangent of theta. All right, so the first thing I'm going to do is draw a picture. So I'm going to go -12, whoops, that's not what I wanted to do. Go -12 and then down 5. So our point is here. This would be -12, -5. And then this is going to be our theta. So we have a right triangle that's formed. And so whenever we have a right triangle that's formed, we can use the Pythagorean theorem to find the hypotenuse. Or you can, if you recognize that you have a Pythagorean triple, you can just use that. But you may not have a Pythagorean triple. So if you don't have a Pythagorean triple, then you're going to just use the Pythagorean formula. In this case, we would take our -5 and square it, add it to our -12 squared, and then take the square root. So a squared plus b squared, take the square root. So notice how I put parentheses around my negative numbers. You must put parentheses around the negative numbers before you square them. And notice how the square is outside the parenthesis. The square is outside the parenthesis. See that? So it's parenthesis, negative number, close parenthesis, then square it. If you square it with the square inside the parenthesis, you've negated the need for parentheses, okay? So make sure that your square is outside your parenthesis. -5 squared is not -25. It is 25. So we have 25 plus, and -12 squared is not -144. If you end up with a negative number underneath this radical, you need to stop and think, did I forget to use parentheses? Or did I square that negative number wrong? You need to ask yourself that, okay? So this ends up being 25 plus 144, which is the square root of 169, which is 13. And so our hypotenuse is 13. So now that we have all three sides, we can write our three ratios. So the first one is sine of theta. So sine of theta is opposite over hypotenuse. So this, if our angle is here, then this is the side opposite. So -5 over 13 is sine. Okay. The cosine of theta is going to be adjacent over hypotenuse. So adjacent is -12 over 13. And then tangent is opposite over adjacent. So side opposite is negative 5 over adjacent, which is negative 12. So that would be 5/12. That makes it positive. A negative divided by a negative is a positive. And that's it. This problem should look very familiar to you because this is the exact same problem that was on your last test. So now we're using it as a review problem. So first of all, we're working with tangent, and I'm going to go ahead and fill out the table and the graph first, and then answer the questions that are at the top. All right, so in the first column, we have all of the angle measurements that we're going to use for tangent. And then inside the parentheses here, we see that we're taking the angle measurement and we're dividing by 2. Well, this is an insider, and we know that whenever we do something on the inside of the parentheses, something to the angle, we have to do the opposite operation that's here. So since this is divided by 2, we need to multiply times 2 here. So we're going to multiply times 2. And so we get negative pi. We get negative pi over 2. We get 0, pi over 2, and pi. So the next thing we need to look at is the tangent values. Well, we know that tangent at negative pi over 2 is undefined. So it's going to be undefined here and here. So if you graphed all your tangent graphs for your homework, you should know that both of these ends are undefined. All right, so at negative pi over 4, which now is negative pi over 2, our value for tangent is going to be negative 1. And then at 0, it's 0. And then at pi over 4, it's 1. So you have to have those values correct, or your graph is going to be wrong. All right, so now we're going to do our changes that we need to make to tangent. Well, this says we are going to multiply by 3 and subtract 1. So over here, we're going to multiply by 3 and subtract 1. So negative 1 times 3 is negative 3, minus 1 is negative 4. 0 times 3 is 0, minus 1 is negative 1. 1 times 3 is 3, minus 1 is 2. So now we're ready to graph. So we're actually graphing this line of angles and this line of tangent values. So we're going to put in our asymptotes first. So we have an asymptote at negative pi and one at pi. And then we're going to put in our points. So we have at negative pi over 2, we have negative 4. So negative pi over 2, negative 4 is way down here. Then we have negative, at 0, we have a negative 1 right here. And then at pi over 2, we have 2. Pi over 2, 2. And that's our tangent curve. It's kind of stretched out, but you can sort of see it. It's a little off the graph. Now let's answer the questions. Amplitude. Tangent doesn't have amplitude. NA, or undefined. Period for tangent. Well, we have to look here for the period. Okay, how long is it before the tangent curve repeats itself? Well, we go from negative pi to pi. So that's going to be 2 pi. The next thing, vertical asymptotes. Well, we wrote them in here. We know they're at negative pi and pi. And then vertical shift is down 1. And that's it. Now let's take a look at the next graph. The next one is cosine. So we're going to change our angle first. In this case, we have a phase shift. Phase shift means that we have a shift to the left or to the right from our angle. In this case, we have plus pi over 2, which means we have a phase shift of negative pi over 2. Remember, it's always the opposite. Negative pi over 2 is going to be our phase shift. That means I'm going to subtract pi over 2 from all of my angles. And when I do that, I get negative pi over 2 for my first angle. Then I get 0. Then I get pi over 2. Then I get pi. And then 3 pi over 2. And those are going to be my angles. Now the period is going to be, how long does it take me to get from negative pi over 2 to 3 pi over 2? Well, that's just 2 pi. Another way to look at it is we didn't change the period. We didn't make any changes right here to this x as far as stretching or compressing. So we didn't change the period at all. We just had a phase shift, which means we just shifted the graph left or right. We didn't change the period. Okay, this is cosine. So the value for cosine at 0 is 1. So for cosine, we start with 1. Then we go to 0. Then we go to negative 1. Then 0. And then back to 1. So those are the values for cosine. And to cosine, we are going to multiply by 2 and subtract 2. So multiply by 2 and subtract 2. So 0 times, multiply by 2, subtract 2. 2 times 1 is 2, minus 2 is 0. 0 times 2 is 0, minus 2 is negative 2. Negative 1 times 2 is negative 2, minus 2 is negative 4. 0 times 2 is 0, minus 2 is negative 2. And 2 times 2 is 2, minus 2 is 0. Okay, so we're ready to graph this now. Cosine and sine waves don't have asymptotes, but they do have amplitude. And in this case, our amplitude is going to be this number right here. That's in front of cosine. Whatever we stretched it by, that's going to be our amplitude. This time our amplitude is 2. And we have a vertical shift of negative 2 or down 2. Okay, so let's go ahead and put in this graph. We have at negative pi over 2, we have the value 0. So at negative pi over 2, we have the value 0. At 0, we have the value negative 2. At pi over 2, we have the value negative 4, which is off the graph a little bit. And then at pi, we have negative 2 again. Oops. And then at 3 pi over 2, we're back at 0. So it looks like a V, but it's really not a V. I could keep drawing these points along my graph, and this actually makes a wave. And it's not a V shape, it's a wave. So make sure that your graph looks like a wave and not like an absolute value, because it is not a V. Okay, in the last graph, we're going to change cosine to sine. So this was a typo. This should have said sine, not cosine. So we need to change that on all of our reviews. So change cosine to sine, and now we're going to graph sine. All right, so first of all, we have a phase shift again. No change to the period, but we do have a phase shift. This time, we have a phase shift of plus pi. Remember, we have to change the sign. Plus pi. Okay, and so to all of our angles, we're going to add pi. Add pi, whoops. So to 0, we have pi. To pi over 2, we add pi, we get 3 pi over 2. Then if we add a pi to a pi, we get 2 pi. And then 5 pi over 2. And then we get 3 pi. Okay, so the sine values at 0, sine is 0, and then 1, and then 0, and then negative 1, and then 0. And so 2 pi, what we're doing is multiplying by 2 and subtracting 3. So over here we're going to multiply by 2 and subtract 3. So 2 times 0 is 0, minus 3 is negative 3. 1 times 2 is 2, minus 3 is negative 1. 0 times 2 is 0, minus 3 is negative 3. Negative 1 times 2 is negative 2, minus 3 is negative 5. And then 0 times 2 is 0, minus 3 is negative 3. So this one's going to be really off the graph, but that's okay. We can manage. So at pi, I'm going to be at negative 3, which is right here. And then for for 3 pi over 2, I'm going to be at negative 1. Negative 1 is right here. And then at 2 pi, I'm going to be at negative 3 again. And then at 5 pi over 2, I'm at negative 5, which is way down here off the graph. And then at 3 pi, I'm at negative 3 again. And I can keep going down and up and down and up and making another wave. So here's the wave. Okay, so just make sure that your sine wave and your cosine waves look like waves and not like zigzags or absolute value symbols. And that's the, oh wait a minute, we're not done yet. Amplitude. Amplitude is 2, same as before. You look at this number right here to see what the amplitude is. That's 2. We stretched it by 2, so amplitude is 2. We didn't change the period, so it's still 2 pi. Another way you could look at that is, how long did it take for the pattern to repeat? So from here to here, how far is that? Well, from pi to 3 pi is 2 pi. Or you could look at it this way. From pi, well, I just said that. From pi to 3 pi is 2 pi. That's what you need to look at for period. Okay, vertical shift. This one went down 3 units. Down 3. And that's it. And we're done finally with our review. Good luck on your test. I hope you all get 105s. And if you need help, come to tutorials. We're here to help you. Don't forget also that we have reassessments for the last test if you need to come in and do that. Good luck, Longhorns.